So again, your computer has the physical hardware down here. This will be your CPU, which is your central processing unit, the chip that has your RAM, random access memory, which is where all the memory gets stored in your computer when you're running programs, your hard drive or SSD. Does anybody know what the difference between a hard drive and an SSD is? So, go
Faster.
ahead. Go ahead.
I said the SSD is faster.
Yeah. So the SSD is essentially faster. Basically, a hard drive is what we used to use a lot. It's a device and it has a physical disk on it. And that disk spins and it has a little read arm, kind of like a record player. Many of you may not remember record players. It was before my time, so I'm pretty sure it was before your time. But basically, it's the same concept. It spins and it reads from that disk, a hard drive. So if you click on something and you hear your computer start whirling up, it's usually the hard drive or the fans, one of the two. And SSD, on the other hand, is faster because all it is memory. It's like a flash drive. It has little flash drive modules on it, which is why it's called a solid state drive, SSD. There's no moving components on an SSD. It's just memory modules all organized on this SSD. They're connected through little, I forget the official term, but I'm going to call them buses, or little data highways. There's a controller module that all this connects to, and your data is stored on the SSD, solid state drive, versus an HDD, which I don't know what that acronym stands for. There's too many acronyms in tech. Basically, a hard drive is a moving component. An SSD is solid. It makes it faster. It also makes it more efficient, and it runs cooler, right? These spinning components, they spin, they get hot. Plus, there's a limit on how fast this disk can spin and how fast it can read and write. With the solid state drive, there is a limit, but it's limited by the components on the device, not necessarily the physics of spinning a disk around a centralized location. So that's why SSDs are faster. They're also more expensive, right? They cost more money. All right, so that's your physical hard drive or hardware, I'm sorry. It's down here at the bottom of your computer stack, if you will. Then typically we'll have an operating system on top of that. The operating system is responsible for relaying all of your commands to the hard drive, translating, the fact that I can talk through a camera, which then connects to you all. The operating system is responsible for doing all that underlying processing, interacting with your hardware. So on top of your operating system, you'll have programs. So right now I'm running, oops, that's not a Z. I'm running Zoom. I have Moodle open. Sometimes I have Word open and I have Mail open, right? All of these different applications are running on top of my operating system and interfacing with my operating system, sending commands down to the operating system. Then the operating system interfaces with the hardware and translates those commands. So that's a typical computer stack, if you will, okay? You have your hardware, your operating system, and then your programs on top of it. I tried to find a nice little graphical, like YouTube video about this, but don't know those videos speak our language. So I had to do it myself. So that's basically the basics of a computer in a nutshell. Right? You have your hardware, your operating system, and your programs on top of that. Of course, you have your peripherals, so your mouse, your keyboards, I/O, which is input and output devices, your cameras, I have a wireless mouse. It's invisible right now. I have a wireless keyboard. I have speakers. I have well, that's not connected to my computer, but a ring light or a printer. Those are all peripherals, right? And Your operating system interfaces with those as well, which sends them commands to receive my video, to receive my audio, all of that different stuff. Well, a virtual machine attempts to abstract the hardware and replicate it, right? So you can run multiple operating systems on it. So as always, you have your hardware down here, right? And there's two types of virtual machines, right? Well, two types of hypervisors. Right? The hypervisor is responsible for replicating that hardware, right? That's the actual system that replicates your hardware and you can run stuff on top of it. So there's two types of hypervisors. There's a hypervisor, what is it called? You would think I would know this as many times I teach this. Type 1 and type 2. So the type 1 hypervisor, right? Hypervisor 1. Now my pen no longer works. Here we go. All right. The type 1 hypervisor, right? What it does is it sits on top of your hardware and it replicates that hardware. It creates simulated CPU, simulated RAM, simulated memory, simulated hardware, hard drives, and SSDs. From there, you can run multiple operating systems, such as Windows or Mac or Linux. On top of those operating systems, then you can run multiple programs. So it replicates with one set of hardware, you can replicate many different operating systems, many different operating environments. This is how AWS works. You don't actually get a physical computer when you create an AWS instance. You get a virtual machine. This is called a VM. The VM is that operating system, virtual machine, all right, which is made possible by hypervisors, okay? So when you create an AWS Linux instance, you're creating a virtual machine on top of an H1 hypervisor, and then you can run multiple programs in that virtual machine, okay? So that's an H1 hypervisor, all right? Then we have type 2 hypervisors. Again, we still have our hardware. Then instead of the hypervisor being directly on our physical hardware, we have an operating system, such as Windows, okay? And then we run a program, a type 2 hypervisor program. From there, we can create multiple operating systems again. Inside those OSs, we can run multiple programs. That's a type 2 hypervisor. All right. So an example of that would be VMware Workstation. VMware Workstation is a type 2 hypervisor. You can run operating systems using that, and I'll show you that right now. So I have my operating system. I have Windows running right now, right? This is just a program, VMware Workstation Player. From there, let's see. I have multiple different operating systems here. Let's see, let's run this one. I think this is a Ubuntu instance. Please ignore the name. It's part of my research. It helps me organize it. So I'm running a virtual operating system on top of my Windows operating system. Okay, and you see it's loading up. This is, I believe this is Ubuntu. It might just be Debian, which are types of Linux. And give it a second. I'm not going to wait here too long for this to boot. Come on. And again, this is a form of a type 2 hypervisor, and it's opening, here we go. It's opening a new operating system, which is Ubuntu. That's not the right password. It's opening Ubuntu. And you see, Ubuntu looks a lot like Windows. So if any of you all are really heavy into tech, I encourage you to learn Linux. Ubuntu is a great introduction to Linux. But you see, now I have basically a new operating system. It's completely separate environment. Anything I do in this virtual machine does not affect my Windows machine. Has zero effect. Because that type 2 hypervisor acts as an intermediary, you won't see any of the issues. Say, for example, I run some malicious software in this virtual machine. It won't affect my Windows machine. So for security researchers, we use virtual machines a lot because it isolates our operating environment from our real computer. I don't want this malicious software to access my real computer, so I run it in a virtual machine. Okay? Any questions about virtualization, hypervisors? And I'm going to show you this again. I'm going to open up VMware Workstation again once this shuts down. Because I want to show you that you can set the configuration of these virtual machines. A type 2 hypervisor allows you to do that. So click on that virtual machine again, edit virtual machine settings. And you see I can set how much memory it has, how many processors, the hard disk or hard drive. You can connect your physical CD drive to it. How do you want to set up your networking? So I'm bridging it. Basically, it's connecting directly to my network interface card. You can also network address translation, NAT, which translates it. Your network interface card then acts as an intermediary. So yeah, type 2 hypervisor. Any questions?
Nah, but that's awesome. There it is.
Yeah, so that has made, a lot of technologies today possible. Virtualization. What happened to my stuff? I'm trying to operate all these different windows and just a second. Let me exit this. There we go. All right. So all of that to say, the JVM is a type 2 hypervisor. Okay. So again, we have our hardware. And then we have our operating system, which for me is Windows. And for you all, it's Windows, Mac, Chrome OS, however it may be. Chrome OS is a little bit different. And then what happens is we run the Java virtual machine on top of our OS. And then any programs that are written in Java run on top of the JVM. Okay. Any program you write in Java runs on top of that JVM. Can anybody think of why the JVM exists? Why do we use a JVM? I kind of explained it before with security research. Well, it abstracts our hardware and our programs from our operating system, right? So when we run a program on the JVM, what we do in that program, there's a little bit of built-in security because these programs cannot access our physical hardware. It can't skip those intermediaries, the JVM, the OS, right? If it could interface directly with the OS, that could introduce a lot of problems that were consistent with C++, which is the precursor to Java, right? So the JVM provides a little bit of security and protection. It also isolates our programs from one another. So these programs cannot access each other, right? This cannot happen unless they do some sort of communication. But they can't access the memory of another program, right? Previously in C++, you can access any piece of memory you wanted, basically. JVM, it isolates those programs. You cannot access another program's memory, which is what makes Android so secure. Android, most of the programs are written in Java. Each program is isolated in its own little sandbox. All right. So this is the JVM, right, at its core. All this stuff right here. Any questions about the JVM?
No, sir.
All right, so how does Java work? When we write a program, right, we write our program, hello world. Fantastic. Which is what we'll do today, because your homework this weekend is to write a program that reads and writes from the console. And hopefully I'll get to that in the next 14 minutes. Okay. So we write our program in Java. Then the next step is to compile our program, into Java bytecode, which is illegible by humans unless you are just that tech savvy. The Java bytecode is for the JVM. That's what the JVM reads, is Java bytecode. The JVM translation, I don't know if that's the official term, but that's what I'm going to call it. The JVM then translates that into machine code to be run on the hardware, right? And this is what you'll see with binary. This is, bits 0010011. Oh, that's 00. All of that machine code will be sent to the operating system, which is then run on the hardware. So those are the steps for Java. You compile it into Java bytecode. You run it on the JVM, which then translates it into machine code, machine executable code. So that's the gist of the JVM and how Java works and kind of the basics of Java. Any questions before I switch gears and I start actually programming?
Not that I can think of.
All right. Anybody else? And Josh, I cannot see your face. That'll be the one warning. The next time will be a boot from the class. All right.
I got you. I don't know why it's acting up. It's been doing that if you've been paying attention. I don't know why. It's probably about to open up though, a little bit.
Okay. All right. So let's switch gears now. Let's actually do some programming. I know that's what you all are here for. So I'm going to use the Java visualizer, which is really good. I used to use it last semester. Oh, I use it in my programming 1 class. We're going to use NetBeans in this class. But for this introduction review, I'm going to use the visualizer because you can see what's going on. So all I did was Google Java visualizer, pops up in your browser. Cool. Start off with a clean program. This would be technically, when we go to NetBeans, this would be a .java file, okay? The first thing you always need, Krishan, is what?
Your public class.
Yes, sir. So public class, I'm going to name it review 1. The name of your class, so public class are keywords, you have to have those. This is what I name it. It must be one word. So if you have multiple words in here, there's no spaces allowed. So you can't do review 1 like this. It has to be review 1. All right.
Can you
Cool.
kind of just zoom in a little bit? I really can't see on my phone if you don't mind.
Now I'm going to upload this to the YouTube channel as well. Review 1, opening bracket. Whenever you have an opening bracket, you need a closing bracket to correspond with it. Every time. The next thing you need in every program you create, hold on, I'm getting some, I think it's my computer. Hold on just a second. All right. So every time you have a program, you need your main method. So public, static, void are 3 keywords. Main. All right. Main method. String, brace, args. That will never change. You'll need these 2 lines every single time. Now, what you name your class may change, but this main method, this whole structure never changed, which is called your method signature. We'll talk about methods later, but just know this is the starting point of every program you'll write. When you write a program and you press run, the JVM will look for your main method to run. Whatever code you put in that main method, that's what will run. Okay. And if you want to, you can work with me while I do this. So you can pull up the Java visualizer, you can work with me however you want it to work. So let's create hello world. Let's make our first basic program. System.out.println hello world. So I do system.out.println. That's your basic printing to the console. Whatever you put in these quotation marks, double quotation marks, is what will be printed to the console. So if I say hello world, if I do system.out.println, programming is fun, so they say. System.out.println, welcome to Java 2. Also, if you notice, you have to have your semicolon at the end of every single statement in Java. Every single line of code, you need a semicolon, unless it's your class or your main, which you need an opening and closing bracket for. All right. Visualize execution, which is basically your run, and we can go step by step. This is our program output down here. So if I hit forward, you see it says hello world. Hit forward again, programming is fun. Hit forward one more time, welcome to Java. And that's it. That's all the code that's in my main method. You see the return value, which we'll talk about later, is void for our main. That corresponds with void right here. Any questions about your first program? That's hello world.
No, sir.
That I do expect everyone to be able to do come next week, because we're going to keep going. So make sure you have this down pat. If not, I do have office hours today from 12 to 2. If that doesn't work, you need time later in the day, we can schedule some time as well. All right, next step, reading and writing from the console. So that's what your assignment will be on, I believe, which is reading and writing from the console. I gotta open that up for you. And I give you the code to do it, basically. So in order to read from the console, we just wrote to the console, which is system.out.println. To read from the console, we need something called a scanner object. And this class, you'll learn what objects are, but for right now, we just need to know we need a scanner. So scanner input equals new scanner system.in. System.in tells us we're reading in from the console. Whenever you want to do a scanner, what do you need to import at the top of your program? Ben, do you remember?
Got to import java.util.
Yep. Thank you, Krishan. Import java.util.scanner. You have to import that if you want to use the scanner. All right. Let's read in something real quick. Let's read in a number from the console. So we have variable types and data types. The three main data types we'll use in this class are ints, int number 1, doubles, number 2, and strings, word 1. Integers hold whole numbers. Doubles hold decimals. Strings hold characters, words, sentences, paragraphs, all that stuff. You have to put a whole number for an integer. You can put whole numbers or decimals in a double. And you can put anything in a string. It'll just convert it into a string. All right. You cannot put a word into an integer or you'll get an error. Same thing with a double. But you can put numbers into a string and it'll just convert it to a string. So let's read a number from the console. So number 1 equals integer dot parseInt input dot next line. And I'll explain what this does. So we know number 1 is an int. So I'm expecting a whole number. Okay. Input dot next line. Input is our scanner object. So we're going to read something from the console. What are we reading from the console? Dot next line. So what do you assume we're reading from the console? Can anybody tell me? The console is just, right here, you can put, not right here, stdin, you can put stuff into the console down here. So what do you all think we're reading from the console?
The numbers that are actually in there.
Yep. But specifically, the next line. That's it. Input is our scanner that reads from the console, and we're reading the next line. In our console, the next line would be 20. All right. So we read the next line. Integer.parseInt, all that does is convert whatever is in these parentheses right here and right here. It converts it to an integer. So when we read in the next line, convert it to an integer, what do you think the value of number 1 will be?
Should be 20, right?
Correct. So let's visualize that. So we go forward 1, we create our scanner object right here in memory. So this is memory over here. I forgot to explain that. So when we read number 1 from the console, the value of number 1 is 20. All right, go back 1 step. So when we run this line, number 1 equals input.next line. It's going to read 20, then convert it to an integer. Number 1 equals 20. Any questions about that?
No, sir.
Mine, whenever I put it in, like I keep getting these error codes, like even in the beginning one, like CSC circles dot CEMC, assertion failure, see console log for backtrace. That's what I keep getting
What
on
is the
anything.
error?
Here, I'll run it again. Well, it's stuck on please wait processing your code. Like the button for that is just
Oh.
grayed out now.
So share your screen.
All right.